Alright, good morning. Hope everybody's doing well. Let me take a look at Canvas.
Quite looking forward to many days off.
Yeah, I'm going to sleep. Which would be
I didn't
nice.
sleep enough last night, so I had a huge migraine, went a little blind.
Oh no. Migraines are horrible.
Yeah, I go actually blind or I can't read.
Really? Wow.
Yeah, my sight goes whack. I run into things and stuff.
Yeah, I've not had like the visual aspect of migraines before, which I count myself lucky. All right. Well, hopefully everybody turned in their SLP. It looks like I'm missing a number of submissions from this section, but the second section I've only got about half the submissions in, so
I feel like having it at 8 in the morning probably threw a lot of people off. I myself thought it was due at midnight, but
pretty much everything's been due at 8, I think. So
yeah, I get it. It's just most classes are. I turned mine in, but I just
yeah,
feel like
that could be a factor. All right. Well, if you have not turned in your SLP and you have slip days left, you can still use a slip day for that.
Didn't you say that when you turn in one, it kind of counts for the other person as well?
Yeah, I only need one per group. So if you're working with somebody, as long as one of you turned it in by the deadline, you both get credit.
Okay, I was wondering if that explains why half the people didn't turn in, because you didn't need everybody to turn in, just only the ones in one per group.
Yeah, except most people seem to be working alone. So.
Oh, okay.
And it really kind of varies from year to year. Some years everybody works in groups. Some years everybody works alone. It's kind of interesting how it changes. Alright, let's see. I'm messing around with CUDA, trying to make my primes calculated to multiple trials by division per cycle. Cool. CUDA's fun stuff. If you mess around with GPUs, NVIDIA has a programming language for them called CUDA that is pretty fun to mess with. Let's see. Doing the same thing. Turned mine in. Good. Not sure how well my poster turned out though. Feels kind of bland. Well, these posters are pretty minimal, so I wouldn't worry too much about, if the look and feel of the poster seems off or something. Don't worry about that. If you've done work on PA5 and you turned in a poster for it, you're in like great shape, right? I mean that's the real goal.
Do you mean SLP?
SLP, yeah. What did I say?
PA5?
Oh, no. Sorry, yeah. SLP.
Everybody's tired.
Yeah. Well, plus I'm reading comments while I'm talking, and people are talking about SLP. Yeah, but eyeballing these, they look good. Do we need to comment for PI5? What did I say in the rubric?
Doesn't it say that we have to comment in this one?
I think
it
so.
Something about descriptions.
Yeah. So let me get the exact wording out here.
Pro tip: just change it after. You'll never know.
I think PA4 I said you didn't have to comment, and then a lot of people didn't. Alright, code is indented based on nesting. Each section is preceded by comments describing that section's purpose. Lines are commented to describe the reason for the line. Yeah, so that's 10 points out of 100. So definitely comment PA5. And yeah, I'm still not imposing like a commenting style on people, but we want to develop a sense for like what good commenting is, right? What does it mean to have a meaningful comment on a line? And so you want to avoid things like, you know, I equals I plus 1, and putting a comment that says, you know, set I equal to I plus 1. Don't do that. But, you know, a comment that says, you know, increase the tally count of how many times we've seen this phrase is like not only saying we're incrementing this thing by 1, but it's saying why we're doing it, and it's saying what this variable represents, and good stuff like that. All right, so so I do have office hours listed for tomorrow morning. Remember, tomorrow's a holiday at Clark, no classes. I do have office hours listed for tomorrow, but they're at, I believe, 11. Maybe it's 11:30. Let me look. But I'm not going to do 8:30 office hours because I'm going to sleep. So tomorrow, 11 o'clock to 12. So if you need final help with PA5, that's your last chance to get it from me. Would be tomorrow during office hours. But if there's anything we want to talk about with respect to PA5, associative arrays, parsing input, we can do that in class right now. Just give a shout, and this is the best place to talk about it.
Can we work with the arrays for a little bit more? Just because I know that it's going to be on the final, and I just want to make sure we really have a good solidity to it.
Definitely. So let's play with arrays in Bash. Let's see. Let's make an array test program. So let's just read a line from the user, and let's save it in an associative array. So let's just say declare dash a data saver. And so I'm going to say data saver bracket $line. Let's make this a little fancier. Let's set a counter equal to 0. And let's save that counter into our array with an index of whatever the person typed in. So here's the setup. The person's going to say, you know, hello. And here's our data saver array. And at index hello, we're going to store a 0. And then the person's going to say cool, and at index cool, we're going to store a 1. And if they say bye, then at index bye, we're going to store a 2. And we're going to basically, you know, record what the person typed in this array, but we're going to do it by using the thing they typed as an index. And then we can store, you know, whatever we want in that corresponding value. So let's just keep track of how many things have been entered. And we're just building up an array of stuff, right? So the user will type something, we'll save a number in that element of the array, and then let's dump out the array. And I need to look this up because I will get it wrong otherwise. So for name in, exclamation mark, sorry, $, curly bracket, exclamation mark, data saver bracket at. Alright, so when we're done putting in all of this information, when we hit a Control D up here, we're going to iterate through our array of what we call keys, the things that we've used as indices. And we're going to do a for in loop, so each time we go through this loop, data will be the value of another index that we've seen. And we'll just say, you know, data equals, we'll print out data, and then data saver bracket that thing equals, and we'll print out data saver bracket, whatever that thing is. Alright, so that's our setup. I don't expect this to work the first time. Alright, say something. Hello, cool, bye, hello, haha. This is fun. Weird stuff. Alright, then I'm going to hit a Control D. Oh, I knew that was going to happen. Typo. All right, so so then when we loop through our list of keys or indices, it runs 3 times through this loop, and the first time it said data equals bye and data saver bracket bye equals, oh that's wrong, and then data equals hello and data equals cool. So I wanted to store consecutive integers in here, but I messed that up also. String curly bracket, data saver. Alright, so when we do this for in, if we have spaces in our keys, then those are going to get pulled out one by one, because a for in breaks a string up by spaces, which is why we're turning spaces into underscores in PA5. So let me just run my program but put in some things that don't have spaces. And so we go through and we pull out our data, and so hello was saved with a value of 0, and testing was saved with a value of 1, 1, 2, 3 was saved with a value of 2, and so on. Alright, so key takeaways from this, right? These things that we're pulling out, these are indices, right? These are things we're using to index the array, to access elements inside the array. And so data saver bracket hello, data saver bracket bye, and so on. And you know, I just happen to store consecutive integers in here because, you know, that's what I did. I stored this variable counter. But we could store anything that we want in here. And so this data, for example, is associated with this key or index. This has no spaces. So on the code side, you declare your array like this. That makes it an associative array. We can store something by saying array name bracket and then whatever index we want. And it can be a string, or it can be, you know, a variable that evaluates to a string. And then we can iterate over the keys or the indices by using this funny $, paren, exclamation mark, variable name bracket @. And then when we want to read information out of the array, it's $ curly bracket, and then just array bracket index. Do you notice anything peculiar about the output here, though?
Not off the top of my head.
Hello is 0?
Hello is 0, right, which is what our counter was initialized to.
Oh, sorry.
Oh, that's okay.
Is that a board based off of when you put in the input, it didn't organize the output?
Yeah, it's out of order, right? We typed in hello, testing 1, 2, 3, but when we read it out, first we got weirdness, and then testing, and then this has no spaces. And the order is very strange. It's not this for in statement is not bringing things out in the same order that we put them in. Does that seem weird?
That does seem weird, given that it should have processed from the top to the bottom, but
Yeah.
it's all mangled.
It's all mangled up, exactly. So why is this? This is the nature of associative arrays. So associative arrays, right, these are these things that we sometimes call hashes. And a hash is not just stored sequentially in memory. There's a meat grinder that your indexes go through that turns your indexes into integers, so that the system underneath can take your index and say, oh, this data is stored at location 3. This is stored at location 1. But that process of converting your index into an integer is not, based on the order in which you enter the indices. It's based on the index themselves. And so it may be doing something like, for example, taking the ASCII code of each character here, adding them together, and then doing some modular arithmetic to come up with a number. And when you do that, there's no guarantee, in fact, it's almost guaranteed, that the order of the indices will not be the same as the order that you type these in. And there's a good chance if I type these in a different order, they'll come out in the same order. I don't know if that's true or not. That would be a fun test to try, though. So yeah, it's there's never a guarantee on the order in which these things happen. That's sort of the punchline. And that's okay, we can work with that.
Your face cam disappeared again.
Yeah. Interesting. I'm just messing with cameras here. Will we go into hashes and hash collisions 222? Absolutely. We're going to talk about these associative arrays as hashes in a lot more detail in winter, and you'll also code in C an implementation of a hash table, and that will include dealing with what we call collisions, which is where hashes stop being ideal in their performance. So yeah, we'll definitely be revisiting this topic a lot. And then we'll use hashes extensively in 223 as a data structure in Java. All right, well, good time for an attendance ping, so go ahead and send me a note. Let me know you're here.
So I got a question about the finals. Is the length of the finals the same as for midterm?
So the finals are an hour and 50 minutes. For most
okay.
classes, including our classes.
All right.
And we'll talk about the final next week. The final will definitely include a bunch of programming questions, but I'm also going to include more short answer, multiple choice, fill in the blank kind of questions. I think because we've got all this Linux stuff that we've been talking about and learning and so on outside of just Bash programming. We're learning concepts and awk and sed and regular expressions and all this. So there'll be a section of questions on programming, but also a section of questions on kind of like the concepts that we've been using. And we'll do some review next week. We'll spend a day going over, the topics that we've covered and things that you should be prepared for the final exam. So the final is an hour and 50 minutes, so 110 minutes. And let's see, this class in 215 is at 12:30, so I think the 215 final is probably right after the 224 final for this section. The other section of 224 I think is on Tuesday, but there's a final exam schedule posted on Clark's website.
Can we use like Notepad again like we did on the midterm?
Yeah, try to use something that won't modify your formatting, because I got a lot of answers on the midterm that, if you had a variable I, it was uppercased if it was in the beginning of a statement, and the indenting got mangled and stuff like that. So definitely spend a little bit of time figure out, how to use Notepad or something that that doesn't munge your formatting, and make sure, of course, you know how to turn it into a PDF. And so if you go to Clark EDU, final exam schedule, so there's the schedule. So 10 o'clock daily classes, final exams from 10 to 11:50 on Monday, December 6th. And then if you're in if you're in 215, uh, 12 o'clock and 12:30 daily classes will be 12 o'clock to 1:50. So you get 4 hours of finals if you're in 215, as well as this section. There's no proctoring on the final exam, so I don't use a lockdown browser or camera or require you to keep your camera on or anything like that. So as far as I know, there's no need to make any special arrangements for that. All right, cool. Other questions? Has everybody signed up for winter term?
I am.
Can I use data saver line equals data saver line plus 1? I believe so. It never hurts to break things into separate steps, though. But you can try it, and if it works in one step, go for that. All right. If you haven't signed up for winter quarter and you're planning to, I'm going to ask you to please do that sooner rather than later, just in case something happens, like there's an overload on one class. I'm not going to overload the in-person class as far as I know, because we don't have space for it. So. And when I looked this morning, there were only 5 seats left in that one, so if that's super critical to you that you take the in-person class, you definitely want to sign up as soon as possible. All right, let's talk about sed. So we talked about awk yesterday, and awk is a way to process typically a text file with the idea of we want to do something with the individual fields on each line of the file. So you have, you know, a comma separated file containing a bunch of numbers, and you want to do something with those numbers. You want to make a file containing the first number and the fifth number so that you can send it to a plotting program, for example. So that's part of what awk is all about. Sed is really geared towards I want to break up my file as collections of lines. So you're processing your file line by line rather than so much field by field. And so sed's a good program for doing this. And so sed is the stream editor, right? And ed is the editor that, you know, we originally had on Unix before there was a visual version, VI. And ed would let you type in commands to change the contents of a file. And then sed is the batch or stream version of ed that lets you specify a file name and a number of things that you want to do to that file. And this sed command basically reads the file, applies these changes, and then, you know, writes the output to standard out. And so similar to awk, the basic structure of a sed command is sed, and then a program, and then an input file. And the program is a series of you know, 0 or more commands that sed understands. And if we have a more complex program, then we can easily fit on one line. We can say sed-f and put in the name of a program file and an input file. And now it will read the program from this file, and it'll apply those commands to each line of the input file. And when you read manual pages, right, if you haven't caught this yet, you know, things that are in brackets are optional. So sed, you know, there's some optional options. There's a program, which would be a script, and then in brackets there's an input file. So again, just like awk and most commands, if you don't specify a file, this reads from standard in, which means we can pipe commands to it and so on and so forth, which you've been doing in PA5 to process your input.
Wait, there's no difference between sed program input file and sed-f program input file?
This is a program written explicitly in the command, so sed quote s/x/y/g quote. This is the name of a file containing commands like that.
Oh, sorry,
right?
I missed that.
That's okay. And it's similar to what happens with awk. Awk, we can do the same thing. We can say quote print $1, or we can have the name of a file that has, you know, print commands and such. And we'll do both of those today. So we're going to keep playing with our foods file. And if we just say sed foods, sed foods with an empty program, right? Just quote, quote. Well, this just reads our input file and it writes out each line to standard out. So not very exciting. It's just like, you know, the cat program. All right, so what do our programs look like? Our program is a series of statements that look basically like address, comma, address, and an instruction. And if we were going to write this the way that, like, the manual pages might write it, this part is optional. And in fact, the whole address is optional. But I can do something like sed 2, 3, and so now everything between lines 2 and 3 which is my banana and my Oreos, I can say I want to do some action on there. And my action might be, let's print. Alright, so what's my output look like? There's apple, that's the first line of my file. Here's banana, that's the second line of my file. It got printed twice. Here's Oreos, the third line, and that got printed twice. And then all the other lines just got printed once. And this was the command I used, sed 2, 3 space p. So p is an instruction for print. 2, 3 says, do this instruction on lines 2 through 3 inclusive.
Where can we find a list of such instructions?
Oh, you can find them online. I think you can probably dig them out of the manual page for sed, but that's a very long, well, that's not that long. I'll give you a handful of instructions to get you started, but yeah, you can dig these out online also. They may also be in our textbook. Let me see. I haven't actually looked to see if sed is in there. Nope, I don't want that one.
I was just curious. You don't have to look right now.
Yeah, well, I'm curious too, actually. Well, somebody check the textbook and see if it's in there, but not now. But yeah, we'll make a list of commands here. So P is for print. And when we did this, when we said, sed 2, 3 p foods, it printed every line of the file, but it printed lines 2 to 3 twice, right? And so why is that? There's a default behavior that sed does, right? If I don't specify anything in my program, it still shows me the contents of the input file. So by default, sed reads a line from your input file, prints it out to the output, and then executes an instruction on it if you've got an instruction specified. And sometimes that's useful, but sometimes we don't want to have that behavior of copying input to output automatically. So we can put a -n switch, which says don't copy to standard out. So if I say sed-n empty program foods, nothing gets printed, right? It read from the input. There was no default copy to standard out, and I didn't have any instructions saying that you should print anything. But now if I say 2, 3 print, now I see lines 2 through 3 of my input file. And so that's a pretty useful way, pretty easy way to pull out lines between two points in your program. And we can do a line number. We can also use a $sign to represent the last line of the file. So this will print everything from line 10 down to the end of the file. And it's that P that's telling it to print. We can also use regular expressions. So instead of putting in a line number, we could say, let's look for a fruit. And let's print, let me do my sed-n. And let's just print on lines that contain the pattern fruit. And so that prints out every line that has the word fruit in it. We can do that with grep, right? But we can do grep with this. How does one copy to standard out? Most things write to standard out by default. So, like sed and cat and ls and such, those things by default are going to standard out. But where the output of a program goes is really a function of the program itself. almost all of these programs that are command line commands are written to generate output to standard out, and then we can redirect what standard out means by saying greater than or pipe and so on. But if a program is made to write into a file, there's not much we can do to actually change where the output goes. I don't know if that is what you were asking. All right, we have another command Q, which is quit. And quit just does that. It says, you know, the program should stop running now. So if we say sed, and we can say line 5 quit. So without the -n, sed's default behavior is to read from the input file and write the output to standard out. But when I get to line 5, I'm going to execute the instruction Q, which means quit. So if I do this, I get 1, 2, 3, 4, 5 lines of output, and then sed exits. So that's one way to print out the first 5 lines. Now we can also just say head -5 foods, and that will do the same thing. But this is a much more general utility. All right, so we can make longer programs. So here's a program P1. It says on line 3 we should print, line 4 we should print, and line 4 we should quit. So if I say sed dash don't echo the input, execute the program P1 on the file foods, this will print out lines 3 and 4 of my file. Basically, when it got to line 3, it matched this address, and so it printed. And when we got to line 4, it matched the address and it printed, and then when it was on line 4, it also said, oh, I should do this instruction, quit, and so the program exited. All right, another instruction is A, which is append. And it goes along with I, which is insert. So insert is before the current location, append is after the current location. This mirrors those two commands in VI. When you're in VI, if you say A, it starts inserting after the cursor location. If you say I, it inserts before the cursor location. So there's harmony with sed. So here's a different program which says if you're on line 2, let's append the following statement. This was added after line 2. And then whatever line you're on, let's go ahead and just print the contents of that line. So 2-line sed program. So I'll do sed-n for no automatic echo. I'll use my P2 file as the program. I'll run it on the foods file, and so there's the apple and the banana, and now there's a new line of output which says this was added after line 2. So that's this 2-line file right here. Alright, so A is an append after, I is an insert before. So here's P3, and whenever we find the word cookie in a line, we're going to insert before that line. Here comes a cookie. And whenever we find the word cookie in a line, we're going to append after that line. That was a cookie. And then we're going to print every line. And so if I run that, every time that we get to a cookie, it's sandwiched by a pair of additional lines we've just put into our output. As with most things in Linux, we can put a backslash at the end of a line to break up a long line. and say continue to the next line. And that's something we can do everywhere in Unix. If I want the date, I can say DAT \, and I can finish typing the word date on the next line, and it executes the date command. So so we can do this. And say, okay, when we find a pattern cookie, we're going to insert before the current line. And here I'm saying let's insert an empty line, and then the word here comes a cookie. And then when we find a cookie, let's append that was a cookie followed by an empty line. And then let's go ahead and print whatever was in our input. So now if I do this, I got the same behavior, but I just added some extra space before and after these modified lines. So here I've used a change command. I've said let's look for a pattern containing the word fruit, and if we find that, let's change our input line to the line no fruit. And so all the fruit's been removed from my file and just replaced with this one liner that says no fruit. So we have a C command for change. And of course we know this version. There's a command S, which is a substitute. And we can say substitute any appearance of CHEAP with inexpensive. And so instead of saying cheap, it says inexpensive. And that's the way that we've been using sed for like PA4 and PA5 and such. So, but that's another command. So we can do substitutions. For PA5, how do you detect if a user entered Control D to stop collecting phrases? So there's a pair of ways to do that. One would be to do something like while read input do done, and this section of your code will iterate, and each time the user types something in and hits enter, input will be set equal to whatever they typed in, and this section of your loop will execute. And when they hit Control D, you'll kick out of here and you'll come down to whatever's after the done statement. So that's the easiest way in terms of number of characters. The other way you can do this, which I suggested last week, is after you say, you know, read input, you can check the value of $?? That's that status variable in bash. And if that's not equal to 0, then you know the person hit Control D, and you can use that to break out of your loop. Yeah, question?
I just said, oh, okay.
Okay, yeah. This is the easiest way though. It's just while read input, and it automatically keeps looping until you hit Control D. And then if you're doing either of these, if you run your program, but you feed an input file, when it gets to the end of the input file and it tries to read past the last line, it will detect that as if the person had hit Control D and kick you out of your loop. So you can use it with an input file or with a just typing in from the keyboard. All right, and with the substitute command, right, there's always the /G option at the end, which says substitute as many times as you can on the line. So that's just the said version that we started with. All right, there's another cool switch we can use. So all of these things that we're doing, right, none of these actually change this file. The file's just used as an input source, and the changes are written to standard out. So we can specify another switch -I. And -I says I want to actually change the file itself. And when we say -I, we can put some name down here. And two things will happen. One, the current file will get copied to a new file called file with name added to the end of it. And then it will go through and it will make these changes and write them into the file that you're processing. So for example, let's do a -I.backup, and let's substitute a space with an underscore everywhere. Foods. All right. So sed by itself with just this program would say, you know, replace all the spaces with underscores. It would just show us, you know, a new version of the file, but the foods file would be unchanged. But if I do -I, the foods file should be modified. And so if I do this and I look at foods, it's actually changed the file in place. But it's also made a copy of the original file. In this case, since I said -I.backup, it's created a foods.backup. And that's the original input file. And so -I is basically saying copy your input file to file, you know, .whatever, and then run sed on that new file, that backup that you made, and redirect the output to the original input file. So you can make your changes actually affect the file itself. All right, wow, we're running out of time here. What's the best stuff to tell you about in the last 2 minutes? We can append, we can substitute. Actually, that's a pretty good coverage. Yeah, that's not a bad starting set of commands. So you know, again, main idea of sed is, you know, we're going through a file, we're processing by lines instead of fields, and we can specify an address range. We can specify a regular expression, a pattern that we're searching for, and so on. And when these conditions are satisfied, we can have, you know, some set of instructions executed to, you know, make changes or produce output. We can also delete. So for example, I could say sed-n 5,12 delete foods, and this will delete lines 5 through 12 of my foods file. And I'm not doing the -n so that by default it prints, but I could also put a print statement in if I wanted. But so anything from 5 through 12 inclusive gets removed, and then the remaining lines just get printed by default. All right, that's all I got for said. So things to keep in your bag of tricks, right? Play around with it if you like. Try some of these things at home. Have a fantastic break. I will see you on Monday, and we will start talking about processes in Unix. And we'll spend a few days going over process creation. We'll look at processes in Bash and in C. Send me an attendance ping on the way out, and have a great one, and I will see you next time.
Thank you.
Thanks.
Bye-bye. Happy weekend.
All right, thanks. You too.
Have a happy holiday.
Thanks. Same to you.
So I have a quick question for you here.
Yeah.
So